All right, we're going to talk about systems of linear equations. So linear equations, meaning the x's have a power of 1 degree in all these x's. The a's are all constants, and so is the b, all just real numbers, and n is a positive integers. So there could be 5 or 4 or 3 variables there. So when we call one or more of these linear equations and with the same variables, we call it a system, and that's what we're going to be doing. We'll be finding solutions of these systems. All right, so we have 3 cases. We have the case where the system is inconsistent, we have the case where the system is consistent, or we have consistent with one solution, and then we have consistent with infinitely many solutions. So let me just give you pictures with good old y equal x, y equal like lines, or y's and x's. We're not going to be dealing with y's and x's, but if I had no solution, I would have 2 lines that would be parallel. There'd be no intersection point. Exactly one solution, that would be the 2 lines intersecting, and that would be the one solution. The infinitely many solutions, and I know you learned this a long time ago, 2 lines that are right on top of each other. So the other line is right on top, so that's infinitely many solutions. So those are the 3 cases that we will be addressing. All right, so what we like to do is we'd like to take this system and put it into a matrix. So when I just use the numbers that are in front of the x's, that's called the coefficient matrix. And notice I use the 0 for the x2 here. And here I'm putting these numbers in here for the second row, 2, 2, and 10. And again, I put a 0 in for the x1, and then the 1, the 5. So this is the coefficient matrix. When I'm talking about the augmented matrix, that's when I'm pulling in these numbers on the other side of the equal sign. So this would be where the equal sign goes, and this is the augmented matrix. There's lots of words in this, so you need to make sure you're getting comfortable with them. All right, so these 3 elementary row operations I want you to get good at, so let's talk about what they are. So one of them is to replace a row by the sum of itself and a multiple of another row. And I'll illustrate all of these. So this is the hardest one to kind of talk about, but we'll be doing a lot of it, so you'll get accustomed to it. Interchange 2 rows, or multiply all row entries in a row by a non-zero constant. Okay, so the idea is when I do any one of these 3 things, that the solution set to the new matrix is the same as the solution set to the original matrix. So we have a way of saying they're row equivalent. All right, so what I'd like to do is I'd like to get a 0 in this position right here. So I'm going to encourage you to keep this notation. I want you to, and you're going to want to write this down so you can keep straight what you're doing. A lot of mental math. So if I multiply row 1, that's this, by a -2, and then I'm going to add it to row 2. So multiply by -2 and add to 2, I get 0. Multiply by -2 and add, so that just stays 2. Multiply -3 by -2, that gives me a 6. Add it to 10, that gives me 16. And multiply this by -2, I get -16 plus a 6, that gives me a -10. Okay, so now that I've got zeros beneath this 1, I'm good there. So now I want to get a 0 beneath this 2. What did I do first? Oh, never mind. I wanted to multiply this row here by 1/2 so that I could get a 1 here. So I want to multiply this row by 1/2 to get a 1 here. So 16 divided by 2 is 8. -10 divided by 2 is -5. Okay, so now I want to get a 0 below this 1. So this leading 1 here, I want to get a 0 below it. So if I want to get a 0 here, that results in this, I want to take this row 2, multiply it by -1, and add it to row 3. We always have to add the rows together, so I multiply this row by the negative number to get rid of that. So multiply by -1 and add 0. Multiply by -1 and add -8 plus 5 is -3. multiply by negative 1, so I get 5, subtract a 2, that gives me a 3. All right, so my next job is I want to get this to be a positive 1, so I multiply row 3 by negative 1/3, and I get to here. All right, so now I've got 1s on the diagonal here, or not quite a diagonal, but leading 1s. As I come in on this row, and in this row, and this row, there's 1s that are the first thing that I see. So now I want to get 0s above the 1s. So there already is a 0 here, so that's nice. There already is a 0 here, so I want to get a, whoops, I need to go back here. I want to, there already is a 0 here, so I want to get a 0 in this position. So I want to multiply this row by negative 8 and add it to this row. So multiply row 3 by negative 8 and add it to row 2. So negative 8 and add, that gives me a 0. Multiply by negative 8, that gives me 8, minus a 5, that gives me a 3. All right, let's keep on going here. So I want to get a 0 in this position now. So to get a 0 in this position, I want to multiply this row by 3, row 3 by 3, and add it to row 1. So multiply by 3 and add, that gives me 0. Multiply by 3, that gives me a negative 3, add 5, add to 8, and I get 5. All right, I have a solution. So this is the x1 position, right? So this says x1 equals 5. This is the x2 position. This says x2 equals 3. This is the x3 position. This says x3 equals 1. So that is the solution. So what if the question had been, is this system consistent? Is there a solution? So let's look back. We could have stopped at this step right here, because this last row would have said negative 5x3 equals 5, and I can see there is a solution. This row here would say negative 2x2 minus 15x3 equal 9. I could substitute what I have in here. Yep, I could have found out what that is. And this row here would have said x1 minus 3x3 equal 8. And I could have used the information here and plugged it in. So I could see a solution is there. So this triangle of zeros shows us that there will be a solution to this system of equations. So this is the place I could have stopped.